Alright, y'all. Today we are going to learn about acceleration in a distance versus time graph. So you might be like, wait, say what? I thought acceleration and deceleration were in a speed versus time graph. Well, today we are going to do it in our distance versus time graph. I'm going to show you what it looks like. First off, shout out to the 100%ers today. You will get your exit tickets back at the end, but still want to shout you out. Who rocks? You rock. What we are back speed. Our objective is we will analyze acceleration in a distance versus time graph, and our homework is to finish the packet. Our note number 1. In a distance versus time graph, an upward line means that an object is moving away. A flat line means that an object is stopped, and a downward slope means that an object is going back to the start point. So our note 1 continued. I know that we are looking at this graph right here. We know it's moving away from its start point from 1 to 3 seconds. It's increasing its distance. It's stopped from 3 to 4.5 seconds because it's staying at the same distance and time's going on. And it's moving back from 4.5 to 6 seconds because it's decreasing its distance going back to the start point. Note number 2. An upward slope with a straight line means that an object is moving away at a constant speed. So if I take a look at this graph, I know my object's moving away. It's increasing its position, but it's doing so at a constant speed. And I can prove that by taking the speed at different points. So I know the speed at time 1, its distance was 10, and its time was 1. So I know that its distance divided by time, its speed was 10 meters per second. And let's go all the way to the speed at time 5. I know that my distance was 50, and it did it in 5 seconds. So its speed, its distance divided by time, was 50 divided by 5, which is 10 meters per second. So I know that it's traveling at the same speed as time goes on. Note number 3. An upward slope that curves up means that the object is accelerating. It's increasing its speed over time. And I can prove that by taking the speeds at some times on the graph. So I know my speed at time 2 is its distance was 8, and its time was 2, so its speed, 8 divided by 2, is going to be 4 meters per second. If I go to the speed at time 5, I know that its distance was 50, and its time was 5, so speed is its distance divided by time, which was 50 divided by 5 was 10 meters per second. So this shows that it is speeding up. Note 4. An object with an upward slope that flattens out means that the object is decelerating or decreasing in speed. So I can take the speeds again. I know my speed at time 1 is that it went 2 meters. So its distance divided by time was 2, divided by 1 was 2 meters per second here. And if I go all the way to time 4, so I go 1, 2, 3, 4, its speed at time 4 was 4. 1, 2, 3, 4. So I know its speed, its distance divided by time, was 4 divided by 4, which equals 1 meter per second. So this shows it's slowing down. Let's look at our practice questions. 1. Draw a line of an object increasing speed at a constant speed. Why is the speed constant? Number 2. Draw a line of an object that is stopped. Why is it stopped? Number 3. Draw the line of an object that is decelerating. And why is it decelerating? Look at the object below. I want you to take a look at this graph and answer the questions. Why is this object stopped, or when is this object stopped? When is this object increasing speed? What letter is it accelerating? What letter shows it at a slow and constant speed? What letter shows it at a fast and constant speed? What letter shows it returning to the start? And which line is most similar to the student running to the door in class, and why?